Let's take a look at complex rational expressions. Now this first one will just be numbers, so it doesn't really fit our steps, but I'm going to put down the steps anyway. And so we got 3 over 4 minus 5 over 6, 7 halves plus 4 over 3. Though actually, well, even with these numbers, the steps will work if I go through them. But these are the steps for simplifying a complex, they say simplify the expression. Simplifying a complex rational expression. Now a complex fraction, complex rational expression, basically you have a fraction inside of a fraction. Typically complex rational expressions, we have variables involved. You have x's in there or y's or whatever. Technically this one is still a complex rational expression. Now our first step, we want to factor all our inner denominators. Now when I say inner denominators, we have this outer fraction, and when we have inner fractions, the fractions inside. So 3/4 is inner fraction, the 5/6 is inner fraction, 7 halves, and 4/3. And each one of those inner fractions has an inner denominator, the 4, 6, 2, and 3. So when I say factor them all, and again I'll do it even though numbers you typically don't need to do this. 4 is 2 times 2, minus, and 6 is 2 times 3, over 2 we can't do anything with, and 3 we can't do anything with. So that'd be our first step. Our second step is figure out the LCM of all the inner denominators and multiply everything by it. Now when I say everything, I'm talking about what's separated by pluses and minuses, fractions, separated by pluses, minuses, and so forth. Now our LCM. Let's start with our first factor. I'll start with the 2. Now we're looking for the greatest number of 2's in any single inner denominator. We got 2 of them here. We got 1 of them here. We got 1 of them here. We got 0 here. So the greatest number of 2's in a single inner denominator is 2 of them. Our first fraction here. So we're going to have 2 of them. Well, then I go to my next factor, which is 3. And I'm looking for the greatest number of 3's in any single inner denominator. There's none here, 1 here, none here, 1 here. So the greatest number of 3's in a single inner denominator is 1. So that's our LCM. And 2 times 2 is 4 times 3 is 12. So we're going to multiply everything by 12. And I put these in this form just so we could easily see that. But I'll multiply that fraction by 12, minus, and I'll multiply this fraction by 12, and I'll multiply this fraction by 12, and I'll multiply this fraction by 12. Most people don't have to actually factor the numbers. You can look at the 4, 6, 2, and 3 and see that the LCM is 12. Okay, well let me put it back the way it was. So I got 12 times 3/4 minus 12 times 5/6 over 12 times 7 halves plus 12 times 4/3. Now multiplying everything by it, we're going to see some things cancel. Here we got 12 and 4, those are both divisible by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. Here we got 6 and 12, they're both divisible by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. Here we got 12 and 2, they're both divisible by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. And here we got 3 and 12, and they're both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So we got 3 times 3, which gives us 9, minus 2 times 5, which is 10, over 6 times 7, which is 42, plus 4 times 4, which is 16. Always in math, combine together like terms, combine together numbers. 9 minus 10 is negative 1. And 42 plus 16 gives us 58. Now actually, that's as simple as it gets, so that would be our answer. But let me go ahead and write down our other steps. Our second step was to multiply by the LCM. So step 3, and actually let me go ahead and put it up here. So after you've multiplied by that, and multiplying by it means get rid of parentheses, combine together like terms, and so forth. We're going to factor the top, factor the bottom, and then step 4, cancel if possible. Well, as I look at this one down here, obviously I'm not going to be able to cancel anything with a 1, so that's why I didn't go further on that. Let's take a look at our second problem. So we got x plus 2 over x minus 1 minus x minus 7 over x minus 5 over 5x minus 17. Step 1. Factor all of our inner denominators. We have two inner denominators, the x minus 1 and x minus 5, and there's no factoring there. So go directly to step 2. I'd be shocked if you have to actually do step 1 on any of these problems. Step 2 is figure out your LCM of all your inner denominators. So let's do that first. We'll go with our first factor, the x minus 1. I'm looking for the greatest number of x minus 1s in a single inner denominator. There's 1 here, there's none here. So the greatest number of x minus 1s in a single inner denominator is 1. Then I go to my next factor, the x minus 5. And I'm looking for the greatest number of x minus 5s in a single inner denominator. There's none here, there's 1 here. So we'll have 1. And that's our LCM. That's what we'll multiply everything by. So we'll multiply it by our first fraction. And we'll multiply it times our second fraction. And then we're going to multiply it times the 5x minus 17. Now you could multiply it times the 5x and times the negative 17. That'd be a lot harder than just setting it up this way. So if it's not a single fraction, then just put them next to each other like that with parentheses. Well, before we actually multiply that through, here's an x minus 1, here's an x minus 1. Remember, if one's on top, one's on the bottom, you can cancel them. Over here is an x minus 5, here's an x minus 5. So those are going to cancel. And we're left with x minus 5 times x plus 2 minus x minus 7 times x minus 1 over our denominator. Okay, up on top here, x times x is x squared. X times 2 is 2x. Negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. Minus, and I'll multiply these. X times x is x squared. X times negative 1 is negative 1x. Negative 7 times x is negative 7x. And negative 7 times negative 1 gives us a positive 7. All over this. Okay, so combine together some like terms. We've got x squared, 2x minus 5x is negative 3x, minus 10, minus x squared, negative 1x and negative 7x is negative 8x, plus 7, all over our denominator. Now remember, if you have a negative out in front of your parentheses, that's going to flip the sign of everything inside. So this negative here is going to flip the sign of the x squared, the negative 8x, and the positive 7. So the top part becomes x squared minus 3x minus 10 minus x squared plus 8x minus 7 all over x minus 1, x minus 5, and 5x minus 17. Combine together like terms. X squared minus x squared cancels. Negative 3x plus 8x is 5x. And negative 10 and negative 7 gives us negative 17. Now our third step is to factor the top, factor the bottom. Well, these are already factored as much as we can. So our last step, cancel if possible. See how we have a 5x minus 17 here, 5x minus 17 here? Those are going to cancel. So we have 1 over x minus 1 times x minus 5. And that's our answer. Let's take a look at this one. I meant to actually get rid of these right here before we started, because we won't always be using the same book. So different editions, different page numbers, different author, different everything. Okay. Let's look at our third example. We got x minus 3 over x plus 1 minus x over x minus 2 all over 5 plus 2 over x minus 2. First step, factor all of our inner denominators. We have x plus 1, x minus 2, and x minus 2. We don't have any any factoring to do. Step 2, figure out our LCM. We'll start with our first factor, the x plus 1. I'm looking for the greatest number of x plus 1s in a single inner denominator. There's 1 here, none here, none here, so we'd have 1. I go to my next factor, the x minus 2. I'm looking for the greatest number of x minus 2s in any inner denominator. A single inner denominator. There's none here, 1 here, 1 here, so the greatest number of x minus 2s in a single inner denominator is 1. So x plus 1, x minus 2 is our LCM. And we'll multiply times our first fraction, the x minus 3 over x plus 1, minus, and this carries along, and I'll multiply times this fraction, times the x over x minus 2. We'll also multiply times the 5, and I'll multiply times this fraction. Well, before I actually multiply it together, this x plus 1 cancels this x plus 1, so those go away. This x minus 2 cancels that x minus 2, so those go away. And down here, this x minus 2 cancels that x minus 2. Let me write down what I have left, and then I'll start multiplying it together. So x minus 2, x minus 3, minus x times x plus 1, over 5 times x plus 1 times x minus 2, plus 2 times x plus 1. Well, up on top here, x times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x. Negative 2 times negative 3 is 6. And here we got negative x times x. That gives us negative x squared. Negative x times 1 just gives us negative x. All over 5 times x is x squared. X times negative 2 is negative 2x. 1 times x is 1x. And 1 times negative 2 is negative 2. Plus 2 times x is 2x. 2 times 1 is 2. Combine together like terms up on top. We have x squared minus x squared. Those are going to cancel. We have negative 3x, negative 2x, and negative x. Negative 3, negative 2 is negative 5, and another negative gives us negative 6x. plus 6 over, combine together like terms down here, negative 2x plus 1x is negative 1x or negative x minus 2, plus 2x plus 2. Well, now we'll multiply the 5 through. So I got negative 6x plus 6 over 5 times x squared is 5x squared. 5 times negative x is negative 5x. 5 times negative 2 is negative 10 plus 2x plus 2. Combine together like terms. We got negative 5x plus 2x gives us negative 3x. Negative 10 plus 2 gives us negative 8. The top part, that was, what was that, step 2? Step 3, factor your top, factor your bottom. Top part is GCF. The bottom part would be the key number if it does factor. And let me come over here. 5x squared minus 3x minus 8. Key number because it's x squared, x, no x, and there's a number in front of our x squared. With key number, we take our number at the beginning times the number at the end. So 5 times 8, ignoring signs, and that gives us 40. Now come up with the 3 columns. We write down all products, give us 40. We got 1 times 40, 2 times 20, 3, no, 4 times 10, 5 times 8. Add them. 1 plus 40 is 41, 2 plus 20 is 22, 4 plus 10 is 14, 5 plus 8 is 13. Subtract them. 40 minus 1 is 39, 20 minus 2 is 18, 10 minus 4 is 6, 8 minus 5 is 3. And I guess we do have the 3 in there. So we're going to use 5 and 8. And what we do with that is we rewrite our middle term using those 2 numbers. Our larger number, which is the 8, will always be the same sign as the middle term. So that's negative 8x plus 5x. Oh, the number we circled is in the difference column, D for different signs. So if the 8's negative, the 5 has to be positive. Now factor by grouping. The first group has an x in common, and that gives us 5x minus 8. Second group has nothing in common, so we'll factor out a 1, and that gives us 5x minus 8. Factoring 1 out actually doesn't change anything. But you always have to factor something out. So they both have a 5x minus 8, so I factor that out, and that leaves me x plus 1. Now the top part, it says GCF. They're both divisible by 6, and my first term is negative, so I'll factor out a negative 6. And that gives me x minus 1. The bottom part is 5x minus 8 times x plus 1. Now step 4 in this one we don't have to do. It says cancel if possible. Well, we have an x minus 1 and we have an x plus 1. That's as close as it gets, but they have to be exactly the same for you to cancel. So this would be our answer. And let's look at our last problem. Got 5 over x minus 1 over 25 over x minus x. Step 1. Factor all our inner denominators. Well, we got 2 inner denominators. We got this x and this x. Nothing to factor. So step 2. Figure out your LCM of all your inner denominators. So I'll start with my first factor, the x. I'm looking for the greatest number of x's in a single inner denominator. There's 1 here, there's 1 here. So greatest number of single x's in a single inner denominator is 1. So multiply that times our fraction. So multiply it times 5 over x. We'll multiply it times negative 1. We'll multiply it times 25 over x. And we'll multiply it times x, or negative x. Well, when I do that, these x's is going to cancel, and these x's is going to cancel. And we're left with 5 minus x over 25 minus x times x is x squared. Step 3. Factor top, factor the bottom. Well, first off, these are both in the wrong order. We want them in standard form. So I'm going to rewrite this as negative x plus 5 over negative x squared plus 25. Technically, you don't have to do it on this problem, but it's just good practice to always put it in standard form before you start factoring. then both of them are GCF. They don't have anything in common, but I notice my first term is negative, so I factor out a negative 1. And that gives us x minus 5. And here I factor out a negative 1, and that gives us x squared minus 25. Well, the top part doesn't factor anymore, but the bottom part is dots. Difference 2 squares. So let me show it over here. We've got x squared minus 25, two terms with a minus between it. You try to write it as something squared minus something else squared. And you ask yourself what times itself gives you each piece. For the x squared, x times x gives us x squared. And for the 25, 5 times 5 gives you that. Now, difference 2 squares says if you can write it in this form, you take what's in your first set of parentheses, you add what's in your last, and you take what's in your first and you subtract what's in your last. So the bottom part factors as x plus 5 times x minus 5. Step 4. Cancel if possible. Well, they both have a negative 1, so those negative 1s cancel. And they both have an x minus 5, so those x minus 5s cancel. So it appears like we're left with 1 over x plus 5. And that's our answer. And the last problem. So let me go ahead and save this.